What iPad is that? Is that new? Where did you get that?
I got it. This is the one I bought, the iPad Pro. I don't know why it's not.
Did you sell your old one?
No.
What?
Okay. So unit circle. Here's how the unit circle works. So here's my unit circle. And if you want to find the tangent, so this is the cosine, because it's the, if I draw in this triangle right here, that's a right triangle, and there's my 30-degree angle right there. And the opposite, this is your 1/2, and this is your √3/2. So, and this is 1, it's a unit circle, the radius is always 1, right? So this is your cosine of 30, and this is your sine of 30. To find your tangent of 30, the tangent is the sine over the cosine. So the tangent is your y over your x, which is 1/2 divided by √3/2. Now, how do you do this problem? A lot of people don't remember because of COVID probably. So it's 1/2 over √3/2. What I do is I basically multiply this by 2 over √3, 2 over √3. That's essentially what you're doing. So this cancels out.
Oh,
now you don't have to actually think of it doing it that way. You can just multiply by the reciprocal.
Okay.
That's why they say multiply by the reciprocal. Now this cancels here and here, and you get 1 over √3, which if you rationalize the denominator is √3/3. So the tangent of this is √3/3. The cotangent of it is the reciprocal of this, which is just √3. Okay, so the tangent, the tangent of 60 is going to equal the reciprocal of the other one, right? So it's just going to equal √3. And the tangent of this, 45, is obviously just 1. So just go around your circle and do that for all of them. So this is going to be negative √3/3 for the tangent. This is √3. This is 1. This is, I'm sorry, -1. Those are all negatives. These are, because it's negative by negative, these are all positives. So these are the same as what they were in the first quadrant, √3/3.
You know what I don't get?
√3.
Isn't cotangent in the third quadrant negative somehow?
No, cotangent is
In the
positive.
delta math, I think it said that, and that made no sense.
No,
Like,
it's
I could
not.
be wrong.
It's positive.
Yeah, so that might not be
Cosecant is cosecant and secant are negative. But,
right. And
this is negative √3/3. This is -1, and this is negative √3. So those are all my tangents, and this is undefined. This is undefined, and this is 0 and 0. So those are all my tangents. The black are all my tangents.
Okay.
So you can memorize them if you want, but what I do for the unit circle to create it and think about it is the radians are actually easier than the degrees, if you ask me, when you understand what they basically are. So here's pi radians. 180 is pi radians.
Right.
So every 30 degrees, if I color code these, I'm going to color them in yellow, and you'll see that, and that. Those are all 30 degrees, and there's 6 of them.
6.
So you divide pi by 6. So there's 1 pi over 6. There's 2 pi over 6, 3 pi over 6, 4 reduce, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 reduce, 9 pi over 6, 10 reduce, 11 pi over 6, 12 pi over 6. And then do the same thing for the 1/4. There's a fourth, there's a fourth, there's a fourth, or the 45 degrees, right? So there's 4 of those, right? So there's 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. Done. It's super easy to write the radians. You don't have to memorize anything or do any tricks or any Michael Scott memorization techniques, right? And then and then this obviously is just negative positive over here, right? This is negative positive. This is negative negative down here. This is positive negative, etc. Positive positive. And it helps you really understand all of everything that you're doing when you understand how that works. So if you're trying to find like, so this is just a big cheat sheet basically, but all you really have to memorize, or not even memorize, all you have to remember is that this 30, 60, 90 triangle, and the bigger side is the X coordinate. So that goes there. Root 3 is bigger than 1. So root 3 over 2 is bigger than 1/2. So there's that, and there's that, and flip them for this. And that's just root 2 over 2. This is 45, so those are the same, right? That and that are the same.
We learned 30, 60, 90s and 45, 45, 90s in like geometry. And we never talked about the unit circle. That's so weird.
Well, yeah, and 30, 60, 90, you can actually see, you can even prove the 30, 60, 90 if you draw this. See how that's a equilateral.
Yeah.
So this is a 60, 60, 60. So if this is 1, so is this, so is this. If that's 1, then this has to be half of it.
That doesn't make sense.
And then if this is half of it, use Pythagorean's theorem and you'll get root 3 over 2 for that distance. And remember how you go from, so that's why you did the special right triangles. 1, that's a 1/2 of it, and this is times root 3. Remember that little trick you did? And for a 45, 45, 90, it was if you're given this bigger side, then the smaller sides are divided by root 2. To go from the bigger side to the smaller, divided by root 2. So 1 divided by root 2 is the same as root 2 over 2. And then you can also see, like you can take this and you can then convert it to the graphing itself, like how you graph these functions. If you take these values right here, let me show you, I'll do it real quick down here. If you take the, oops, that's not what I meant. If you take the units, blank unit circle, or the unit circle, I'll put it up in the corner so you can see it. Like, is that clear or no? Doesn't seem very clear. Why do they have it
there? Which one do you want?
Unclear unit circle? Okay, so there's my unit circle. Okay, so, and really I just need to see that first. No, let's see the whole thing. So if you wanted to graph the, I'm going to help you understand how graphing it works. So here's my graph paper. Here's 1 and -1, because that's the highest and lowest. Here's 2 pi. So this would be pi. So this would be 1/2 pi. And this would be 3/4 pi. And this would be -2 pi. And this is negative pi. And this is -1/2 pi. And this is -3/2 pi.
What are you doing?
Okay, I'm showing you how to graph. Have you done this yet?
No.
Graphing.
Graphing radians.
Graphing.
Oh, like sine graphs and stuff.
Yeah, just graphing. It's easier to think of it in terms of
Okay.
radians, if you ask me. I could put degrees here as well. But if I wanted to graph cosine, for example, the cosine graphs, I'll circle these in red. Remember, that's the X coordinate.
I don't think I need to know this right now, Dad.
You do need to know this soon. So I'm going to show you. This won't take long. Just trust me. So what you can see is the cosine graph. Do you see how it starts at 1? If the radian is 0,
Right.
I'm graphing this
Y is 1
with this. This is my x-axis. This is my y over here. Here's my x and here's my y. Right. So when the radians are 0, it's 1, and then it goes, and it's going to go to at 90 degrees. It's going to be 0, and then it's -1. See over here, it's -1 at pi. it's -1, so it goes down to here.
I just lost a little bit. Why is?
And then at
the x is the
at 3 pi over 2, the cosine is 0. At 3 pi over 2, the cosine is 0.
Why are we graphing with the y?
So this is the radians. The
Right,
x coordinate is radians.
The y is just the
and the y is
cosine.
the cosine, right?
Oh, and if we
the
graph
y
it
is
where
just
the
the
y
y.
is the
So
sine,
my
is
red
the-
one is y equals cosine
Yeah, okay.
of x.
Yeah, I get it.
That's what I'm graphing.
And if it was sine, then it would be 0 there, and it would be like inverse.
But what you can see when you do this is you can see here's your first quadrant right here. Here's your second quadrant. Do you see that? Like if I draw lines here, this is my third quadrant, and this is my fourth quadrant. Third quadrant, this is my fourth quadrant. Then it'll be first quadrant again. And over here, look to the left. If I go to the left, what's negative? What's negative pi over 2? Negative pi over 2 is right here. This could also be thought of as negative pi over 2. Negative 90 degrees because it's going counterclockwise. So this is the fourth quadrant. This is the third quadrant. This is the second quadrant, and this is the first quadrant if you're going backward. And so you can see what the cosine graph does. It goes like this. And then it keeps going. So this one's going to be here. This one's going to be at -1. This is going to be here. And this is going to be up at 1. So there's 2 periods of the cosine graph. And if you do the same thing for the sine graph, it's just going to be shifted. So your sine is your y, right? We're graphing this against the radians against the y. And you'll see that it starts here, goes at pi, it goes back to 0. See at pi, it's back to 0. The sine of pi is 0. The sine of 3 pi over 2 or negative pi over 2 is -1. So it goes down. This one goes down to here, and it ends back up here. So what happens is these graphs are just, look at what the graphs are doing of the sine and the cosine. Do you see the difference between them?
Yeah.
What are they? They're just shifted. Do you see how they're just shifted?
Mm-hmm.
That's why they're called cosine and sine, because they're co-functions of each other, which means if you
that's why
add
secant and cosecant make no sense.
That's right. So the reason that it's called cosine and sine is because they are co-functions. And this is what that means. The sine of 30 is equal to the cosine of its complement, which is 60. These are complements of each other.
Mm-hmm.
That's why they're called co-functions.
And secant and cosecant are complements.
Secant, exactly.
But then why are...
So it's a shift. You see how if I shifted this red graph 90 degrees to the right, that would be at the sine graph.
Right.
So that also is another property that you see.
Why is like sine and cosecant what's it called, inverses, rather than like sine and cosine, or sine and secant and then cosine and cosecant? It's like flipped.
They're reciprocals of each other. It's just defined.
Okay, love you.
Hey, was somebody? I didn't check
Just so
that
you
out.
know, you're on YouTube streaming live. So say hi to everyone. Say hi to the world. Yeah, yeah.
Are you really?
Yeah.
Why do you stream
Say
live?
hi to everybody so you can watch it again.
You don't have to stream it.
Why wouldn't you tell us?
You can record.
The people that you're doing
Hey everyone, I'm streaming live. Hi YouTube.
it.
Wow, you have a
will
big chat.
Check the back door, make sure it's locked. before you
I sure will. Love you, hon.
Love you too, babe.
Love you,
Bye.
Mom.
Bye.
It's the beautiful wife of 204 tutor right there. All right. So the question is, why are they? Well, those are reciprocal functions. So the co-functions are sine and cosine. Reciprocal functions, that's just what they're defined as. the reciprocal functions are the sine of theta is equal to the reciprocal of the cosecant of theta. That's just what it is. They're just defined that way.
That's stupid.
Whatever. But that's also, you could also see like your tangent function now. If you wanted to graph your tangent function in here, y equals the tangent of x, it's going to be the blue over the red. So everywhere the red is 0, that's the denominator. That's going to be a vertical asymptote for the tangent function. Wherever the cosine or the red function goes through 0, that's going to be, you can't divide by 0, right? Tangent is sine over cosine.
Oh,
So that's why you have those.
Those things.
Mhm. And now what you also have is where they intersect. Remember, it's sine over cosine. So that point right there, that will be 1.
Does tangent go through
The tangent
center?
will be 1
origin?
for that. So the tangent at this point is 1. Do you see that?
Yeah.
And so wherever they intersect, it's going to be either 1 or -1. Here would be -1, right? They're intersecting right here. So that would be 1. I'm sorry. I lied. That's going to be a negative over a negative. What's a negative divided by negative? It's a positive. So that's going to be up here again. See to the right here. That's a -1 divided by, or whatever. I'm sorry. It's not -1. Negative whatever it is divided by itself, whatever that number is, which we know it's √3/2, right? Or I'm sorry, it's pi/4 or an iteration of that, right?
Mhm.
At that value, it's going to be 1. Did I do that right? Yeah, it's going to be 1. And so it's going to be 0 wherever the blue is 0. So that's going to be also all the points, because when the cosine is 0 and the sine is whatever, it doesn't matter. 0 divided by 1 is 0. So there's my tangent graph. You can see what happens on my tangent graph. It's going to go like this. It's going to approach up there. It's going to go down here.
Mhm.
It's going to approach that asymptote and go down here. That's my tangent graph. Approach the asymptote, go down here. And you can see how I talked about the second. Here's what is the tangent in the second quadrant. The
Oh.
tangent is negative. What's the tangent in the third quadrant?
Oh, interesting.
It's positive. Tangent is positive in the third quadrant, right? What's the tangent in the fourth quadrant? It's negative. What's the tangent in the first quadrant? It's positive.
I didn't even know that like I knew like what the trig function graphs looked like, but I didn't even know they were like the x was in terms of radians or anything.
Well, it could be degrees
makes a lot more
too. You
sense.
could put these all in terms of degrees if you
Yeah,
want.
but that's like
But
makes more sense.
But if you understand, and radians really do make it. It really is easier to think of them in terms of radians when you understand the unit circle. But now you can also take the cosecant graph. If you want to do the cosecant graph, and I won't do it for all of them, I'll just do the cosecant. The cosecant graph is the reciprocal of the tangent. So I look at the blue, and wherever the blue went through 0, there's an asymptote, right? Wherever the blue graph went through 0, there's an asymptote, and it's going to be where at the peak point where it's 1, the reciprocal of 1 is still 1, and then it's going to flip like this. So you're going to have an asymptote wherever the blue goes through 0 for the cosecant.
Asymptote in the cosecant.
For a cosecant, because it's the reciprocal of sine. So what's 1 over 0 if the sine is 0?
There's undefined in the cosecant.
The cosecant graph is undefined wherever the sine equals 0. So you're going to have blue, or sorry, you're going to have green asymptotes.
Makes sense.
Wherever the blue graph goes through 0, there's going to be an asymptote for the green.
And then for the rest,
and your graph's going to go
opposite
that direction
points.
and that direction. Yep. and this
Hmm.
direction. And this direction.
Cool.
That makes sense. And you can do the same thing for secant. And for cotangent, what you do is you change the asymptotes. So the asymptotes change from
Oh, yeah.
tangent and cotangent. The asymptotes now for cotangent, the asymptotes are going to be where the sine equals 0. So the asymptotes are going to be the same as the green ones. And the graph is going to go, instead of going like this here, it's going to go, it's still third quadrant is still going to be negative. So your first and third quadrant are going to be negative. Second and fourth are going to be positive for the cosecant, but the asymptotes are at different places now. So it will be like this. It'll go like this for the cotangent. Said I wasn't going to do it, but now I'm going to. Y equals cotangent of
And
x
the points
gonna be-
cross there.
Yeah, it's going to be here. And it's going to go like this.
Yeah,
First
that makes
quadrant's
sense.
positive. Second quadrant is negative. So it
Do they cross at the 1 point over here? Or am I making that up?
yeah, they're going to cross it. Yeah, they'll cross at that point.
Okay.
All right.
That's like an easy visualization.
Mhm. Sorry, I didn't draw it very good, but that's the cotangent of x. So that's how all of those graphs work together. So your unit circle really helps you understand graphing all of the trig functions as well. If you understand how the unit circle works, it helps you visualize what's happening with the graphs, and you can literally see tangent or quadrant 1, 2, 3, 4, 1, 2, 3, 4, 4, 3, 2, 1, 4, 3, 2, 1.
Mm-hmm. I only just yesterday learned which quadrants are which.
Yeah.
Because somehow little things like that I've gone the whole time without paying attention to.